A big welcome to today's guest, Dr. Giles Yeo. Now, Giles is a difficult man to sum up in a sentence alone because there's not much he hasn't done. By title, he is Professor of Molecular Neuroendocrinology at the University of Cambridge, but in substance, he's far more than just that. He's authored multiple books, starred in several documentaries, and presented a radio program. He has also won a number of prizes, including an MBE. But putting aside all of these outstanding accomplishments, there is something that makes Giles far more interesting. And the Genetic Society summed this up really well, which is he has an outstanding ability to communicate topical subjects and genetic research widely interpreted to an interested lay audience. So without further ado, Giles, a big welcome to the show. All right, Giles, can I call you Giles? I was actually, it's always a question with doctors, Dr. Giles or Dr. Yeo.
Giles, please, don't make me sound old.
Cool. Perfect. All right, Giles, welcome, and great to have you on. And I think the first place, because of the topic we're going to cover, I would really love to understand what brought you to be fascinated in this topic of A, genetics, and then B, specifically the link with obesity and weight. What was your kind of journey in, and what did you find? What was your entry point?
So it's a good question. First of all, thank you so much, Gigi, for having me on your platform. It's always good for someone to trust me on their platform. Let me finish speaking first, and you tell me whether or not this was a mistake. But no, my entry point, I did my undergraduate. It's one of these things where I was good in biology, and then I ended up doing my undergraduate studies in genetics. In just general molecular biology. But I remembered one module, and I remembered this. This was towards the end of my second year, I believe, at university. I did a lab practical based on fruit fly genetics. And it was just a basic practical. We had to take fruit flies with white eyes versus fruit flies with red eyes. We were crossing them. We would look at the genetics of fruit flies. And I was hooked because while I understood what the genetics was, to actually see it happen with the flies, it really, really got me hooked. And I specialized in it for the rest of my undergrad. I then ended up doing it for my PhD, molecular genetics, in Cambridge. So I came to Cambridge to do my PhD. But then I ended up working on the genetics of the Japanese pufferfish, which is a very niche topic. It's a very niche. It's a very niche topic.
It is. How did you transition from flies? Yeah, to Japanese pufferfish.
So my PhD supervisor was a chap named Sidney Brenner. Now he's famous for those of you who know genetics, famous people, because he won the Nobel Prize in 2002, where he introduced a number of animal models into the study of genetics, including the worm C. elegans, for those of you who know what that is. But he was using pufferfish for one simple reason. So the genome, our genome, the amount of DNA we actually have in us, in humans, it's 3 billion base pairs long. So 3 billion alphabets, for lack of a better term. Okay. Now a fish, or the pufferfish, has a very small genome, only around 300 to 400 million. It's still a lot, but 1/10 the size. Because fish are vertebrates, they have a backbone, and humans have vertebrates, we share, roughly speaking, the same number of genes. It's a bit shocking, but we're actually quite closely related to fish in terms of the number of genes. So if the fish has a genome that is 10 times smaller, it is easier to find and map genes in the fish than it is in humans. So this was pre-genome project. This was more than 25 years ago now, 30 years ago. So pre-genome project, and that's why I did the genetics of the pufferfish. But it was never going to pay my mortgage. I think this is part of the thing. So when I then left, I ended up, by luck, looking for a job, and I ended up in the lab of Steve O'Ratley, who's still my head of department now. And he had just discovered the first couple of genes that were linked to human obesity. So these genes were mutated, causing severe obesity in children, like severe, like we're talking kids, for a 3-year-old child who's 45 kilograms. 45 kilograms, 3 years old. I'm a 75 kilogram human being. So that's how I got in, where we were looking at the genetics of severe childhood obesity. But then, and that's how I got in. But now I study the genetics of all body weight. small, medium, or large. That's how I got into the obesity field.
That is fascinating. And just to go back to the pufferfish, does that mean, is it that we have sort of 3 million overlapping base pairs or kind of the same kind of what they have, we also have, and we have additional that makes us human? Or is it sort of, is a good, decent similarity that we can use as a comparison, but there's also a lot of differences within that?
That's an excellent question. So only for humans, and actually for most large mammals, only 2%, roughly speaking, of our genome encodes for encodes for genes. Okay, the actual stuff that builds us. The stuff in between is not junk. The stuff in between is what turns things off and on, but some of it is junk. Okay, and why they've accumulated, there are evolutionary reasons for this. The fish is very primitive. In terms of 400 million years old, so it's around the time just after sharks evolved away from the fish. But they have the same number of genes, but 20% of their genome encodes the genes. So the hypothesis is the remaining stuff in the middle is obviously going to be important for things that go up and turn on or turn off. And if it's conserved between the fish and humans, it must be important. So there are some junk in humans, for lack of a better term, but the hypothesis is what's conserved in the fish. If it's conserved in humans as well, it must be important.
Okay, very interesting. And I know you said when we first spoke, you mentioned that you looked first at childhood obesity. Was there any reason that you looked specifically at sort of starting from the youngest and going older?
Yeah, so we wanted to look for genetic drivers I think what we were trying to do was to identify pathways that we could learn more about controlling food intake and controlling body weight. And so in order to find out how a pathway works, the easiest way is to break the pathway, either on purpose or by accident. And so once again, our hypothesis was that, well, if we try and enrich for obesity that were caused by single genes, which means that if you break this particular gene, if you have a mutation that you cause severe obesity, then we would then understand what that gene did and we can understand more about it. The reason we started in childhood and childhood obesity, severe obesity in particular, is because of how difficult it is for a young child to end up with obesity. I'm talking 3-4-year-olds here, right? So a 3-4-year-old, for anybody who's had a child or niece or nephew or cousin or brother or sister with 3-4 years old, A, they're very small, and B, they do what the hell they want, okay? So they eat when they're hungry, they stop eating when they're not hungry, and that's the end of the story. You can maybe tempt them with some chocolate, but even then, there's only a limit, they stop eating. And so if you end up with a 3-year-old, okay, who is 40 kilos, for example, then it enriches for genes that are mutated causing this syndrome. The problem is if you go older, say you go past 10 years old, what happens? Well, first, you begin to get pocket money. You're now in school. Maybe there's a canteen. Maybe there's a local shop next. You become slightly more detached from just mom or dad feeding you, okay? And the older you get, then suddenly you watch adverts on TV. Suddenly you have peer pressure. Suddenly there's, do I look good? And not. None of which exists as a 3 to 4-year-old. That's the reason why we started in childhood, in order to try and enrich for conditions that were the result of single gene mutations.
That's fascinating. And so I'm guessing the conclusion then is there were genetic dispositions to being obese. But I'm really curious in the other, and what percentage of children typically have sort of obese, like so I would call it chronic or critical obesity at that early age?
So very, very small percentage, certainly at that level of obesity. And we've been looking now. We can give you a number actually, because we've been looking now. So if we actually look at severe obesity and at the range that I'm giving you, right, 99.9 centile%, so not anywhere in the middle, then we're probably we now know, if we get to that stage, we probably know the cause of about 10% of their obesity, 10-15%. It doesn't sound like a lot, but it does give us a very good understanding of what causes that level of severe obesity. The crucial thing, however, that I just want to say is while there are rare conditions that cause that level of obesity, the vast majority of us, our body size, body shape, feeding behavior is not determined in any way by single gene defects. However, because subtle genetic variations, in genes influence why I look different from you, why I like to eat a little bit more than you, these same pathways. So if you have severe disruption of these genes, you end up with severe obesity, okay, like as I've said. But we now know that very, very, very subtle changes in these genes influence that we can find in anybody walking around the street, okay, influence how large or small and how much we are likely to eat. So different genetic cause, but very often the same pathways are involved.
Okay, so what I'm really interested in is like if we isolate the children who have sort of those genetic dispositions, and you're saying the vast majority don't, and I would assume that the vast majority of people listening have children who don't have a disposition towards obesity. But you mentioned something crucial, that when a child is young, they simply put down the fork, they just stop eating at a point. Mm-hmm. Why does that change? Because it definitely does change. I mean, overeating is just huge, and I don't know the stats. I think this is, you may do, and I'd love to know if you did, but obesity is rampant, especially childhood obesity is the most worrying and one I'd like to look at. But there's definitely a point at which people start not putting down the fork. So my first question is that then behavioral purely? And two, why?
Okay, so there is I think there's probably a nuance there. Generally speaking, the child will put down the fork, except for certain environments. You notice I said, except you can tempt them with chocolate, which you can, okay, under certain circumstances. So now, I think there are a number of things to actually unpick. In the broader society, undoubtedly, we are having more obesity in broader society through all ages, okay, and we know that the heritability of body weight, so in other words, the percentage of body weight that's down to genes versus the environment, is a range, it's quite a big range, 40 to 70%. Okay, so whether or not, and we know this just by walking down the streets or looking at the airport, and you see families, body shapes and body sizes tend to be quite inherited. And so we do try and understand that. But we have increased in weight over the past 30 years. So that's not genes, right? Because our genes haven't changed. So that is a change in the environment. So undoubtedly, while some people are going to be small, medium, or large, the environment has amplified that problem, has amplified the situation that is there. Now, children. So the interesting thing about children, leaving aside the rare cases that we started this conversation about, children are interesting, okay? Because now what is the job of a baby mammal? A baby mammal, which our children are, when they actually come out, their job is to grow as quickly as possible to avoid becoming tiger food. Okay, that is the purpose. You got to come out, and so they latch on to the source of food. First of all, they latch on to a source of food, but that's really, really calorically dense. Okay, and what is that? The boob. Okay, in terms of milk, and so it's the one time in our lives that we're designed to naturally drink our food, and in particular to drink sugar, lactose. Okay, that's the one time in our life we're designed to do that. After that, we're designed to eat the food, not to necessarily drink our food. So in order to grow rapidly, which means that actually, if you actually take young, and this is going to happen for quite a while for young kids, because there's such a developmental process in children, is that they will continue looking for calorie dense foods. So if you gave a kid a choice between a celery stick, just as an example, and a chip, okay, how many kids are going to pick the celery stick over the chip or the chocolate? Okay, whatever it is, because calorically it's just more dense. Then there's another thing where that our children can eat foods that we would taste and are going, oh my God, that was so sweet. How are you eating this? My pancreas has dissolved. Okay, but our palate, and this is true for all human children, actually probably true for all mammals, but true for all human children. Our palate, in inverted commas, matures. You know how we don't eat bitter food when we're kids, whereas now we can drink beer, we like coffee, that kind of thing. It's a more sophisticated palate. We think it's more sophisticated. Well, what it is true is because as you're a little kid, you are programmed to go for the sweetest food possible. Programmed, hardwired to grow quickly. Okay, because we're looking for sugar. So, if you let a child be in the food environment that we're actually living in at the moment, they will always pick the sugary foods. And they're not being bad. They're not being whatever bad words you want to use. They are just following their biology. So we as adults, okay, we as the parents of said kids or government of said of country with kids, have to protect the kids from themselves until their palate matures. So we have to control the amount of sugar. Fatty food, yes, as well. Sugar is the major problem with kids. That's what they go for, and you can eat a lot of sugar. Is to try and control access of sugar to kids. Another thing is, I'm sure you know this, the big problem, or one of the other big problems, is the moment you end up overweight or with obesity as a child, it is very, very difficult to become unobese. So the moment you become overweight, and the likelihood, it's not 100%, obviously, but the likelihood is you're going to end up with obesity as an adult. So tackling childhood obesity, aside from the fact that we should worry about our children's health, is also a way of preventing further obesity problems down the line. So it's a win-win to tackle childhood obesity and childhood dietary approaches.
That's fascinating. Okay, I've got so many questions to follow up with. I think my first one is: does the tendency to crave sugar primarily and sort of, or that be the main anchor, does that change as you get older? I mean, I've heard anecdotally, and I'll attest for myself. Anything that is very fatty, I just absolutely love. Like, I think I would choose fat over sugar, and that's just very anecdotal. But does that change? Like, when you say someone's palate matures, what age does a palate typically mature, and what does that maturity actually look like, and what does that mean?
Now, the answer is, you'll find out as you continue asking me questions that I will give a lot of nuanced answers, because the answers are nuanced. So I think on average, a child or baby to child will love very sweet foods. And then depending on who they are and their parents and where they live, we're probably typically looking at puberty. Couple of years after puberty, the palate begins to, and there's a range, begins to mature, which means that your taste for sugar dips slightly, and you begin to like more complex foods. Like I said, Brussels sprouts, coffee, whatever it is, you start to have the stuff, and that's going to differ because of genes between each child, but on average, that's the case. Now, it's interesting that you should say that you have a fatty, you prefer fatty food to sugary food. Same for me. Okay. Now we know, I'll give you one extreme example, which indicates that there are genetics explaining this as well. So we know, for example, this is an extreme example. This is not once again, we know that 0.3% of the population here in the UK carry a mutation in a gene called MC4 receptor. So if you actually extrapolate that to the UK population, 65 million people, that's 200,000 people. Okay, so that's quite a lot of people. It's not a majority by any means, but they carry and are severely and end up quite large. So these people at 18 years old, if you have one of these mutant genes, you're on average 18 kilos heavier, nearly 20 kilos heavier at 18 years old. Wow. And of that, 15, 16 kilos is fat. Okay, so that's eating too much. But my colleague, Professor Sadaf Farooqi, did an experiment not only on how much food they eat, which is interesting, but on what they like to eat. So she conducted, I didn't do the study. She conducted a study in which there is a type of curry here in the UK called chicken korma, which is an almond-based, sweet-based curry. But it's a curry. It's a chicken curry. And so what she did...
Delicious.
It's delicious. It's delicious.
It is delicious.
So what she did... So the study was this. Okay, she did two studies. Let's start with the curry test, the chicken curry test, where she, in effect, was able to control the amount of fat in a chicken curry by whisking in extra rapeseed oil. sounds disgusting, but the moment you actually emulsify it, and you can actually tell the difference. So she created a Goldilocks selection of the amount of fat, a normal amount, medium, high amount of fat. So she then took normal people with no mutation, you, me, for example, and the experiment was this. You had to go into the room, and there were trays of this food. You tasted each of the three. You ranked the one you liked the most, and that's the one you ate. Okay? So, as you might imagine, if you didn't have the mutation in the gene, some people picked the high fat, some people picked the low fat, some people picked the middle because of our taste. Everybody with the MC4R mutation, everybody, okay, picked the highest fat food possible. So, MC4 receptor preferentially likes fat. Now, there was a second test she did. Okay, now speaking to sugar. Now, I don't know if you know what eaten mess is, but eaten mess.
Also, I can attest to that. Also, being very delicious.
Also, very is. But for those of you who don't know what that is, it's like someone has made a pavlova, like a fruit pavlova, dropped it on the floor and put it into a cup. That pretty much is it. Okay, it's meringue, cream, and fruit. But you can adjust the amount of sugar by the amount of sugar you put into the meringue and the amount of sugar you whisk into the cream. So she once again set up the test, Goldilocks selection of low sugar, medium sugar, high sugar. And she put the MC4R kids adults who liked the fat food, and they did not like the sweetest the sweetest eaten mess. They went for the low sugar eaten mess rather than the high sugar one. So that's a classic example, okay, with just one gene, tweaking just one gene, you're able to put someone like ourselves who prefer fatty food to sweet food. So genes exist to actually explain why this might be the case.
That's so interesting. And does preference typically have any correlation with ability to process that, either fat or sugar? Or are they kind of just, why would someone have a different preference?
Yeah, so and I think, so do you know what the answer to that question is? We don't know. Okay, I mean, we know, so we don't, because a lot of the mechanisms are going to be in the brain, it's very, very difficult to actually unpick a lot of them, certainly at scale. That being said, you are absolutely right. If you are unable to process something, then the chances of you avoiding it because you felt unpleasant once before, or two or three times before, red berry, poisonous, I'd never have a red berry again, for example, that is true because that's what's kept us alive. So I am lactose intolerant as an adult, so I can't drink a great deal of milk, for example. So me and creamy foods, spaghetti Alfredo or something like that, I've never been, it's never rocked my world. Probably because I had a couple of bad experiences, back then. So undoubtedly, the inability to process, or if you have an allergy for something that is undiagnosed that no one has actually told you about, but you in your head going, "Oh my God, I felt ill after eating that." You avoid it because evolutionarily speaking, that's the wise thing to do. So yes, the dislike and like for certain foods can be because of your ability or inability to process it.
Very interesting. And then maybe circling back to the palate of a child, and as you say, parents should know, policymakers should know, schools should know. What then is your advice to parents who have a young child? And I think that I'm looking at this in two ways. One, from a genetics perspective, so maybe kind of just having the information to hand to understand what kind of proclivities a child might have. But then two, from a behavioral perspective, does a child, if a child is given a lot of sweet food early on, does that change their palate? And if so, is that on a genetic level or an epigenetic level? Or is it more a behavioral? And I think there's a fascinating other side of this, which is if you teach a child to be rewarded with a sweet, that is their reward circuit that gets programmed into that child. And then when they are older and I had a long day at work, or I've just done really well, I'm going to treat myself with a sweet or an ice cream. Whereas I think I'm really interested in reframing that idea of what is a treat and what reward habits we program into children. But I'm interested to know from a genetic perspective as well. And if you know the behavioral side, how does that what do parents need to be armed with? What information is really useful for them to sort of look at their child, look at what their child A is eating, and then B, what their child wants to eat, and sort of balance this need for a child craving sugar versus a child, needing sugar? How do they kind of think about that?
So I think that was a very complex question. I don't know if I remembered all the. That's all right. I don't know if I remembered all the parts of that question, but I'll answer it and then we can revisit the ones.
There were about
the
5
sections.
questions in there. That was certainly not a one-dimensional question. Apologies. I'll try to remember what I asked. We can pick apart each.
We will unpick it. So I think the first thing, the easiest answer for what a parent should do is not to restrict sugar or do anything along those lines. The answer, as with most things in life, is variety, literally, and in everything. Okay, variety in everything. Cliche, variety is the spice of life, but that's because that's true. And so, like, literally, just don't try and serve as much. Don't always serve carrots. If you do have a pudding, don't always have pudding. If you're having a pudding, don't always have the same thing. And what then happens is, I know it's more difficult than I said. And my son is 21 years old now, but clearly as a parent, when he was small, if you have 2 or 3 dishes you do, it's a lot easier to manage your life. I understand. I appreciate that. But the answer, undoubtedly, the easiest way, without worrying then about things, is just variety. And that will actually, if you keep the variety going, then that everything else mostly should take care of itself. Now, then there's the question you ask about, undoubtedly what we shouldn't do is use food as treats only. I think every so often, clearly the birthday party, Christmas, whatever it is, there are clearly moments of celebration in which we tie to food. Halloween, and we do tie to food. And I think we should tie to those. It's like Halloween. We don't have Halloween every day. So it's not like I eat sugar every single day. But I don't think that we should say, well, you've been good, you've passed your exams, so therefore every time you pass your exam or whatever it is, you only get something sweet. Okay. I think use variety in your treats, in your rewarding. Go swimming instead. Go zip lining. Do something else instead, right? In terms of doing that, with the odd time you do sweets, so that it's not you are not only training someone to respond to sweet food. Once again, variety there is the answer, because you can train someone to do it. I'll give you the broadest example possible. Let's go cultural embedding, okay, which is going to be, so for example, within Chinese culture, just in general, like actually I am Chinese ethnically, but I'm Western brought up. But if you actually go to China or you go to Hong Kong, they don't have a big dessert culture. It's not, I mean, yes, there are sweets. Obviously, you have sweets, but pudding and desserts are just not the big thing. Like, you'll go to a Chinese a restaurant in Hong Kong or what have you and reach the end of the meal and you'll walk out. There'll be no pudding. The closest thing to a pudding, they typically serve oranges with the bill. Okay, that is the sweet. So you certainly can, and that is not a genetic reason. Okay, because you can teach, because look, I know other Chinese people who were brought up in the West who love their sweet foods. So it's not that is a culturally embedded thing which you can learn. Okay.
Yeah.
And so therefore you can learn whether or not to do it. And with sugar, at least you can probably wean, for lack of a better term, wean yourself off high sugar stuff. That's something which is changeable, because the amount of sugar we need in our lives to live is actually very small in terms of living. Fat's a slightly different story. Protein is definitely not the story at all. But for sugar, we can probably wean off to quite a bit. But no. So let's back away. I think the easiest lesson is just variety, variety, variety. Don't be dogmatic. Don't be too tied down to specific things. And don't worry about Halloween. Like, seriously. And for your kid's birthday, don't buy no sugar-free cake. Have a cake. Okay? But then have variety. And undoubtedly, it is true that you can train, for lack of a better term, you can entrain healthy eating behaviors just from the example I gave you about culture, for example.
Awesome. Okay. And then talking about the healthy eating behaviors, I think that's predicated on someone knowing what a healthy eating behavior is. There are a lot of myths that
go around what is an empty calorie? Are all calories the same? What information does a parent need to be armed with in terms of understanding what a healthy choice looks like or not? And I mean, maybe the answer is, as you say, when it's a child, do not worry about restriction at all. And it's don't think about the calorie. But as they get to sort of teenage years and start to become more autonomous, what information should children be armed with when thinking about their food choices? And also, I'd love your view in terms of, is this only something for someone who has to diet, or is this something that should be preventative, and sort of armed with this knowledge going in and growing up?
Okay. So I think when we're talking, I have never been prescriptive about the way that people should eat. Oscar Wilde said, everything in moderation, including moderation. And that is, I think I paraphrased that. I might have murdered it. But anyway, he said something like that. I still do believe that's true. That being said, if you look at a diet in general, I think there's some simple rules. I hate to use the word rules, but there's some simple guidelines that you can follow that will make it a better diet for you. Whatever type of food, whatever culture you happen to be, and whether or not you're a child or an adult. So there's no child-specific healthiness, I don't think. So I think if you as an adult improve your diet, your child's diet would improve. Okay. And then therefore there's a training effect. And so I think you need to focus on, to my mind, 3 key aspects. There are more. You obviously can focus on more if you wish. But for ease, I would focus on 3. I would focus on making sure that you and your child get enough protein. First piece of information. That's the most important thing. Why do I say that's the most important thing? Because we need a minimum amount of protein to make sure we continue growing, to repair organs, to actually do the stuff. We need it. It has to be there. We can't generate that from inside us. We cannot. Okay. And that number is about 16% of the total energy of your diet from protein on average. Okay. Now, remember, this doesn't mean steak only. It can be steak, obviously, or chicken, or fish, or tofu, or beans, protein of any source. There is a sweet spot, because if you have too much, your body has to get rid of the nitrogen pretty much in it, and it can stress parts of your body out. So there is a sweet spot, and that number is 16 to 17, okay, for that. First thing, okay, making sure there's a right amount of protein. Number 2, fiber. We, as a society, as a species, are not getting enough fiber. We are probably only eating something like 15 grams of fiber a day, when we need, actually the more the merrier, but we should be aiming for 30 grams. We should be having more fiber than as much fiber as possible. And fiber comes from plants. That's where fiber comes from. We need to eat more plants. So 16% for protein, we need to eat more plants, and we need to reduce the amount of free sugars we are eating. Now, free sugars differ from sugar coming from a fruit, in the form of a fruit, because it has fiber with it. I'll make the comparison in which the difference between eating an orange and drinking orange juice. Now, when you drink orange juice, and I want to point out that orange juice has the same amount of sugar concentration as Coca-Cola, exactly the same concentration. And no, it's not better sugar. It's exactly the same damn sugar. Okay. Yeah. Orange juice may have a bit more vitamin C. Maybe it has some minerals, but in terms of the sugar, the same amount as Coca-Cola. The problem is when you drink orange juice.
Sorry, just a quick one.
Yeah, go ask the question.
Even with fructose and sort of, my understanding was always like Coca-Cola, for example, would be sucrose, I believe, and then fructose and sugar. So is when you break it down, is a sugar molecule a sugar molecule?
No. So there is a little bit of fructose in fruit, hence fructose. A little bit.
Oh, okay? Interesting. I thought it was all
99. No. So 99% of sugar from fruit is going to be sucrose, which is 1 molecule of fructose and 1 molecule of glucose. Okay. So there is more fructose, a little, like seriously, the amounts we're talking about is so ridiculously small that it doesn't bear thinking about. It is sucrose we're drinking. Okay. Much like we get it in, the same thing is true for maple syrup, for honey, for agave nectar. They are going to have differences a little here and there, which make them taste different. But the vast majority of the sugar, in effect, is sucrose. which is what Coca-Cola uses. Okay. In fact,
I feel duped. I feel so duped. So I'm sorry,
which is
just because I'm genuinely, I didn't think I'd have something that really surprised me. If I eat a peach, does that mean I'm mainly eating sucrose?
yes.
My
But
goodness.
stop. But there's a big difference between eating the peach and drinking peach juice. Because when we actually drink peach juice, orange juice, apple juice, whatever juice you want to talk about, which is mostly sucrose, our body absorbs it because there's no digestion. There is no digestion. One cut of sucrose to fructose and glucose and we absorb it. In it goes. By eating it, orange, let's just focus on orange juice and orange. On eating an orange, 3 things happen that make the presence of fiber matter. Okay. The first is you chew, which you don't do with fruit juice. The moment you chew, your body senses this and prepares to receive energy. Okay. So your body is now prepared. Whereas when you drink anything, it goes through before you know it, it's in your small intestine and absorbed. Number 2, your body has to work to get the sugar, sucrose, out of the fruit through the fiber. So exactly the same amount of sugar that we might get from a glass of orange juice, which is absorbed in X minutes, then takes, as it travels down your small intestine, that same amount of sugar is delivered over a longer period of time, even though you have eaten exactly the same amount of sugar. Okay, number 2. Number 3, the farther something heads down your gut, fiber, for example, comes out the other side, the fuller it makes you feel because of gut hormones. Which means that if you start your day with an orange, then the fiber is working its way through. It keeps you a little bit fuller through the day. You end up eating less through the day if you've had an orange to begin with than if you've had exactly the same amount of sugar and calories, okay, in an orange juice, but then you're going to feel hungry far earlier during the day. Okay, so the answer undoubtedly is don't drink juice, even for your kids. In fact, I think juice is more dangerous than soda. Why? Because when you're drinking a soda, I am drinking a Coca-Cola. Okay, I'm not thinking this is a health drink. I'm not. The vast majority of the human species think orange juice is healthy for you. And it is just as good or bad for you, depending on which way you're looking, as Coca-Cola is. So drink it as often as you would Coca-Cola. I mean, that's a bad example. Don't drink orange juice. Eat the damn orange would be my excuse. And as a parent,
Interesting. And okay, and thought experiment here. I'm trying to find the loopholes. What happens if you drink a glass of orange juice and at the same time you eat, I don't know, an orange, and you pseudo combine this idea of fiber and juice? Am I thinking about that right? Or is it that the molecules themselves or how does that work? I've always wondered why when you drink and eat at the same time, it doesn't have the effect of just eating.
So this is going to be, I mean, there's another way of asking the question that I've been asked before. Okay. Well, what happens if you have a smoothie? That pretty much is the question you're asking. Okay. So yes. Rather than a juice, you have a smoothie. And the answer is an intermediate. So the presence of the fiber will still slow things down because the fiber is still there. So you still have the fullness feeling, but obviously you're going to have elements where are not attached to the fiber. And so are going to be absorbed more quickly. But you do get the benefit of the fiber being there. So drinking a smoothie, drinking soup, a soup is a bad example because it's not that sweet. But drinking a smoothie is the example you're giving pretty much, is intermediate between eating an orange and drinking the juice. So it's not as good as eating the fruit just by itself, but it's better than drinking the juice.
Very interesting. Okay. And so number 1, 16% protein. And I've got some questions going back to that. Number 2, fiber. You said there were 3. What's the third thing that parents should think about?
The third is to keep your free sugars to 5% or lower. The powdered stuff, any of the nectars, honey, syrups that you have, plus juices, any of those will be considered a free sugar. And you want to keep that to 5% or less. By all means, eat as much oranges as you want because people may, but you still consume too much sugar. But there is a controlling mechanism there because of the fiber. That's who eats more than 2 or 3 oranges? Satsuma is different, they're small. But a big ass orange, typically you have 1 orange and you're going, well, I'm done with oranges, thank you. I'm going to move on to the next fruit, or whatever it is. Whereas the problem with juice is you could drink the juice of 10 oranges, literally, with no effort whatsoever. So the presence of the fiber self-regulates how much of the fruit that you can actually eat. So the chances are you probably, I bet you there are going to be some people out there that can end up eating too much fruit. But for the vast majority of us, like seriously, we don't eat enough fruit.
And does the fiber pass through? I mean, I know that fiber is very good for digestion, but do we tap into any of the calorific resource of fiber?
Yeah, so you're asking all the good questions here. So there are 2 types of fiber. The fiber that we think of as a fibrous fiber, that the sweet, when we eat sweet corn, it comes out the other side, celery, that's the fiber that we can't digest. It passes right through us. It has the effect of keeping our microbiome, our gut happy. So that's very good. And it has the effect of making us feel regular. That's very good. And it makes us feel fuller, so we eat a little bit less. So those are all good things. But in terms of calories, no added calories. There are, however, soluble fibers. Now, soluble fibers, and a good example of a soluble fiber is pectin, the stuff you use to make jam. Okay, so what makes jam or jelly solidify is pectin. It's a soluble fiber. Now, our stomach can't digest fiber, but it's soluble. But the bugs in our gut can ferment the soluble fiber into something called short-chain fatty acids. And these short-chain fatty acids are absorbed by our blood, and we are able to utilize that as fuels. So insoluble fiber, celery, sweet corn, that does come out the other side, but it has benefits. Soluble fiber can be fermented within our gut and gives us some energy.
Okay, very interesting. Very interesting. And then maybe just to circle back to the 16% protein. First of all, in a perfect world, if parents are looking at what they should be feeding their child, so is it a maximum of 16 or is it optimally 16% protein? And then we say, a minimum of 30% vegetables? Or how does like sort of if you're looking at a typical plate, what does the composition of that plate look like for a child in particular?
So this is now a very good question. So I'm not here to try and sell a book. Let me just get, I have given some examples, but I can't remember it off the top of my head. So if you bear with me for 3 seconds, let me just get a copy of my book so I can read from it.
Absolutely, please do.
Right. So it's not 30 grams of vegetables, it's 30 grams of fiber. Okay. So let me just, we'll start with the protein because that's the easiest thing. There is a sweet spot for protein. So too little protein, you never want to have, because that will give your child all kinds of problems. And anyway, broadly speaking, within the higher income countries, we hopefully shouldn't get those problems. You say that, but here in the UK, for example, we have nearly 9 million people. We have 65 million. We're a big country. 9 million people with food insecurity, which is a crime. And so they don't know when their next meal is going to come from, but yet calories are cheap. Okay, in this country, we can get 1,000 calories for 99p. Someone has done the math. Okay, it doesn't mean they're good calories. They come from chips, they come from whatever, definitely low in fiber and definitely low in protein. So you can get you can get calories that are low in protein and low in fiber, and that's not what we're looking for. So there's a spot for protein that we want to pick. Okay, now in terms of, let me just find an example. Where is this? Just to give you an example, okay, there is something called the protein leverage hypothesis, originally studied in flies, the fruit flies, which I talked to you about originally, but then shown in mice and shown in human beings. And the hypothesis was this: the original experiments, which was done in flies, so I'll explain that first, is if you actually gave a diet that was lower in protein, let's just say 10% protein rather than the 16% you need. What the flies did was they then end up overeating to make sure they get enough protein, which means what does that mean? That means they get more fat and more carbs, which means they get fatter. Whereas if you gave a diet that was higher in protein, say 20%, just for sake of argument. They then ended up eating less total food so that they could actually reach the 16% of food. And so the fly leverages the amount of protein to let them know how much food they should eat. They're aiming for the protein percentage, and then they stop eating. Human beings are not flies, but we do pretty much the same thing. So if we have a diet that's poor in protein, ultra-processed foods, for example, okay, chips, whatever it is you want to do, you end up, there is one of the hypotheses is you end up eating more to make sure you get enough protein. And so you need to give someone the right type of food. If you give someone the right type of food, then evolutionarily, we look for the right amount of protein because it's so important to our survival. The only time you don't get enough protein is if you are in war and in famine, like biblical, okay, which we're not in at the moment. So I wouldn't worry too much about your child not getting enough protein. So as long as I don't know what to think about putting a child on a plant-based diet rather than a vegetarian diet. Okay, now I have nothing against plant-based or vegans, please. Okay, but you need to be careful, even as an adult, if you're having a plant-based diet. If you're vegetarian, there's no worry because eggs and milk will sort yourself out. There's no concern. You need to make sure a few things, whether or not you're a child or not. But if you're doing this for your child, you need to make sure you get a variety of protein, which means that if you're eating beans, pulses, which tend to be where vegans will get the vast majority of their proteins from because it's such a rich source, don't just have one source of beans. The problem with some plant-based foods is that the proteins are formed from 20 amino acids, and we need all 20, is that some plants are deficient in one or two of those amino acids. Whereas if you actually eat a variety of pulses, you take care of that problem. If they're doing that, you're not going to have too little protein. But if you're on a plant-based diet, you need to make sure you need to watch your calcium levels, your iron levels, your iodine levels, because oddly enough, we get, in the UK at any rate, we get most of our iodine from milk, okay? Which is an odd thing to say because cows are not particularly high in iodine, but their feed is. We're not Japanese. We don't eat a lot of fish, right? This is the problem. So people who eat a lot of fish, they get their iodine from there. But in the United States and in the UK, okay, the vast majority of the iodine comes from dairy products. And a lot of vegans don't know that. And so if you suddenly go to plant-based milks and don't supplement iodine, you end up problem with iodine deficiency. You don't want that. And vitamin B12, which can only be found in animals, or yeast, but not everyone likes Marmite. So you have to supplement B12 for your kids. So I wouldn't worry about protein. So let's summarize. If you are on a plant-based diet and wish to put your child in a plant-based diet, don't worry too much about a protein as long as you know how people say eat a rainbow of vegetables? Do the same thing for beans. Eat a rainbow of beans. If you can see 2 or 3 different colors of beans on your plate, your protein's going to be fine. But you do need to watch iron, calcium, iodine, and for sure, vitamin B12. The safest way is if you're vegan is to supplement with a... There are now vitamin companies that produce supplements specifically for plant-based diets so that you take one and you know you're sorted. But I think it's almost certainly true that you need to do that if you're choosing to be on a plant-based diet. If you're vegetarian, you're fine because milk and eggs will cover everything.
That's really interesting. And I assume the same logic would apply to pregnancy. So if a mom is pregnant, what those same deficiencies, let's say, was a plant-based parent, and I'm really interested, are there any studies on this in terms of the correlation between either health or proclivity of a child whose parents are plant-based or vegetarian, and or even just health in general? Maybe different diets have different outcomes of children when they, enter the world.
So I'll go with what the pregnant woman needs. The pregnant woman, a plant-based pregnant woman, pardon me. In addition to everything I've just said, a woman, plant-based or not, is going to need folic acid. Just folate, okay? Just so that people know that's out there, and that's what you need, whether or not you're plant-based. Now, Health and veganism is an interesting question, and it's very, very, very difficult to pull apart the lifestyle of someone who chooses to become vegan or plant-based versus the health aspects, right? Because to be plant-based, I'm going to say it, some people always get annoyed when I say this, but it is true. Unlike being a vegetarian, in which you can be dirt poor and still be vegetarian, most of the world actually are largely vegetarian because meat's expensive. So you can be dirt poor and be vegetarian. Being plant-based or being vegan is a privileged choice because we can choose to actually do what we want to do. So it's very difficult to unpick the health aspects from the fact that you're looking at a privileged collection of people who, by its very definition, worry about their health and do everything from that. Now, there are some studies which show that there are certain vegans that have a higher rate in women, for example, that have a higher rate of bone breakages, breaking bones. I don't know how robust the studies are. I don't know, once again, how do you pick apart women who are likely to be vegan versus not? And so that's an area of nutrition which is sometimes overstated, and people claim to say, oh, it's healthy to be vegan or it's not. The major issue is you can be healthy and be vegan. Of course you can. Are vegans typically healthier just in general? I don't know if that's necessarily true because it's very, very difficult to actually pull apart the lifestyle, the person who chooses that lifestyle, and the diet in of itself.
Yeah, that's a really interesting point. It's a classic causation and correlation problem.
Yes.
That's
and
so
diets,
true. I'd never thought of that.
And diets are just very difficult. Unlike a drug, in which when you're testing a drug, you have a placebo, right? Which is just a white powder, which you don't know what it is because you're taking it. It's very difficult to have a randomized controlled trial of a diet. You either are eating meat or not. There is no blinding. This is a chicken leg. You know whether or not you're eating it, and I think that's the issue. And so I think we do need. Look, I study food intake, and we look at data all the time about this. Of course, we do, but we would still need to understand the caveats within the data, what we can say from it. Those are the two things.
Absolutely. And just on that point of health and pregnancy, are there any sort of no-goes? I mean, I know there's your classic don't eat deli meats, for example, or anything that might give you food poisoning. I also heard, and I don't know if you'll know the answer to this, I heard that there is a correlation, and I don't know if this was study-based, this is anecdotal, the correlation between food sensitivities and what a mother ate during pregnancy. And the theory that I heard was the more variety a mother eats, the less likely a child is to have food sensitivities or allergies because they've been exposed to things early on. So, for example, there was the peanut question. I think the peanut one was when a child was, this question of, do you wait until a child's a year old before you introduce a peanut to see if they're allergic? Or are you actually creating an allergy because you're not exposing that potential allergen earlier on? Do you have any kind of information or data on allergies or sort of even or preferences? I think that's an interesting one. Do children develop different food preferences?
Okay. Now, the second one, latterly, what you eat during pregnancy and actually more crucially during breastfeeding, because that's the time where there are you're more developed, taste buds are thinking like that, does influence food preference. That is true. Allergies, okay, I'm not an expert, but a couple of things. You have to be susceptible. You're not going to make yourself become allergic to peanuts if you never had the susceptibility to be allergic to peanuts, just as an example.
Got it. Yeah.
Will it trigger something? I probably will not. I will back away from saying anything because I'm not an expert and I don't want to give any kind of bullshit information. So I would say that for the second half, in terms of food preferences, undoubtedly true. So for people, there's some women I've heard say that, oh, when I'm breastfeeding, I want to eat as bland foods as possible. You know, for the baby. Bad mistake. Eat all the garlic in the world. Like, seriously. So just so that food preferences and everything and that is there, then I think that's the best way to go.
That's so interesting. And with food preferences, does that extend? I mean, should then a breastfeeding mom, for example, think, okay, I don't want my child to have a proclivity for or preference for ice cream, I'm not going to eat ice cream? Or is it more that you just have to accept a child's going to want ice cream because it's sugary and fatty?
So here's the thing, okay? We have to remember that there are certain things that are culturally and socially embedded, and there are certain things that are going to have a genetic influence. Let me give you an example. The love of carbohydrates versus fat. This is what we're talking about. You like fatty food versus sugary food? Same here. Okay? Now that is likely to have a powerful biological influence. The form of which that carbohydrate or fatty food takes is going to be powerfully culturally embedded. So, for example, I do like carbohydrates, not sweet, but I'm talking starchiness now. But because of my cultural heritage, I prefer my carbohydrates in the form of rice or noodles. I don't want to back myself into a stereotype, but this is true. My wife, who's English, she prefers her carbohydrates in the form of bread. And me and bread, look, it's not like I don't like bread, but you can put a pile of bread in front of me. I might have a slice, but I'll leave all the rest alone. It wouldn't tempt me at all compared to something else. So that's a classic example where both my wife and I love carbohydrates, but the type of carbohydrate we would love would then be culturally embedded. Now, back to the question. If you're eating ice cream, what you are talking about is fat and sugar rather than the concept of the ice cream. So I mean, if you're having more sugary stuff and what have you, yes, there is a potential for influencing. I'm trying to think actually whether there's any evidence whatsoever if you have a sugary meal, whether or not that makes it into your breast milk. Because the biology of what you do with sugar and breast milk has to be of a specific fat percentage because that's just so. Yes. I don't know if fat or carbs we eat this way influences what, as long as you're healthy, influences necessarily what comes out in the breast milk. I'm not an expert, but in terms of flavor, volatiles, yes, spices, aromats, that will definitely seep into the breast milk, and that will have an influence on preference later in life.
That's so interesting. I find it such a fascinating thing how much control parents actually have over their children's kind of how the child sees the world, the way they interact with food, the preferences of food that they have. It's both sort of very, I think, liberating and also terrifying in equal measures to sort of know how much influence parents can have over children.
But just to not scare the parents away, because obviously it's one of these interesting things, right? When you walk home, when you first open the door and you bring your first child home in particular, and you've left the hospital and you close the door and you walk in and you go, shit, no one's given me a handbook. I'm gonna kill this human being. 21 years later, he's in uni, he's not dead. So clearly we managed. I'm not here to scare anyone at all. So like literally in terms of the rules, is the most important rule is variety. And as long as you keep that variety rule where you just give a variety of different things, whether or not it's sweet or fatty or anything like that, as a general rule, I think you'll be doing okay.
I think that's probably one of the most reassuring, because that's a very kind of easy principle to follow.
Rather than scare people, parents have enough to be scared about without obsessing over what they necessarily feed their kids.
Completely. Well, Giles, thank you so much. I think that's a really good place. I've taken a lot of your time, and I really appreciate just such an absolute wealth of information and knowledge. So thank you so much. And I think this idea of sort of there being genetic components and behavioral components is just so fascinating, because there are a number of influencing factors on this, and I think the more equipped a parent is, and certainly as a child grows up, the more equipped that child is as well, the healthier choices they can make, and sort of, well, we know the effects of that. So thank you so much. It's been wonderful to speak with you today.
Thank you for having me on, Gigi.